So there's something special, though. There's something special about being the maker and seeing this happen. So because I have a lot of focus on education, I immediately worked to develop a set of best practices that related to integrating making into education. And this is an example of that. In 2008, we conducted summer training intensives, and these were for students primarily from City Heights, and for most of these students, this was their first ever exposure to this technology, or even to doing a program of this kind, even just a supplementary educational program. And so students were engaged immediately into the process of ideation. They had to solve a problem, they had to come up with a concept, they had to work together in teams, they had to present their ideas, they were responsible to one another, they were inventors. And this student group in particular designed a beautiful structure, a sculptural piece that for them was their homage to the idea of community power. And you can see, if this image is here, that it's sitting on this table and they're kind of in the midst of a discussion about how they're going to make it. And they did indeed make it. They made a huge 9-foot tall, in my office all day long, example of what they felt spoke to the importance of power in their community. And for them, that meant both power as individuals, but also the idea of electrical power and consumption and sustainability. And they even completed it with copper panels that when you touched, you closed the circuit on, and it allowed for a bunch of LEDs to light up, and of course those were solar powered. So again, we want people to feel empowered. So starting with the younger generation, the hope is that we are able to build a next generation of inventors and entrepreneurs and decision makers who are equipped to deal with the pressing questions and issues of the day. These are all young kids who are recent refugees, and this is them learning about electricity and electronics. So we're teaching them things like Ohm's law, which otherwise might seem really boring. Basically, we're forcing them to do math and understand equations, but of course you can tell from the looks on their faces that they're having a great time. And that's how I feel that every kid should learn Ohm's law, is with a big smile on their face, because it's amazing. And so just by doing simple acts of letting them create something themselves, they're able to be immersed in the fun of the activity, the wonder of the science behind it, rather than just bogged down by trying to learn things. So essentially, what we've found is that when we include play, when we include personalization, when we allow people, students of any age, to basically be able to make something based on their own desires, their own specifications, it allows them to make the process a lot less painful, and we can teach highly complex subjects. So in this example, we're basically tricking kids into learning by letting them play with remote-controlled cars. In this case, what they've actually done is used an open-source board called an Arduino, which is basically a little computer brain that you can program. And they've made these little cars into autonomous robots. And their goal is to learn computer science, to learn programming, and learn how to write code in order to make these cars move. So it's summer, they're 5th graders. This could be a really boring and daunting task. But what this image represents is a moment in their learning process where we stopped needing to tell them what to do. We stopped needing to explain to them why it was important that they should learn how to write this code. This is a moment where they became so immersed in the act of play and the engagement of making that they took it upon themselves to write more code than we had even asked them to do, because they were getting excited about the ability to make a course, program the computer to tell the car how far it should go, and then when it should turn, and then when it should stop, and when it should turn again, that they were getting a thrill out of challenging one another by changing that course and saying, I bet you can't make your car run through it. And then they would almost trip one another running through the door back into the classroom to plug in their little Arduino boards and write more code. so that they could go and run it again. And so, of course, as an instructor, that makes us thrilled.